I'm entering the final year of my master's degree in mechatronics, which means I gotta do a thesis. I'm not gonna use my robot dog as the thesis. I've actually chosen something much more challenging. I'm gonna build a wheeled bipedal robot with quasi-direct drive actuators. This is gonna be hard. Not only is it gonna be my most complicated project ever, but I'm also building a robot dog in the meantime. It's gonna be expensive, very challenging, and I got only 9 months to do it. If I fail this, I'm gonna have to start paying for school, which would really suck. I decided I'm gonna document building this robot and finishing my master's degree. I hope these videos are gonna be popular because this project is gonna be really expensive and I kinda need some money. This is part 0, so I'm gonna share the main goals of this project. I'm gonna design the main components, the overall architecture, like how these motors are gonna communicate with the microcontroller. I'm also gonna talk about how I ended up in this situation that I only got 9 months to do this. But before all of this, let's look at some cool robots. Here we got our first robot. It's called T-Rex and it's the coolest one out of these all. 20 kilometers per hour, very dynamic, it uses a 4-bar linkage for the legs and just really cool. But I have to say, it's got an unfortunate name, because if you Google T-Rex robot, you're gonna find stuff like this. Moving on, we got Ascento Pro. I really like that they actually show the robot climb in tough terrain, you usually don't see this. And the robot can even walk upstairs. But this is actually not how I want my robot to walk upstairs. I want something more similar to this. So this is Drone 1 from Lynx Dynamics, and it climbs the stairs like one leg at a time. I think this was also taught through reinforcement learning, and you can see the actuators absorb the impact of the fall. Very nice. Then there's also this robot from Ayat Musa, which is quite inspiring because he is actually a mechanical engineering student. So it's nice to see that he builds cool stuff like this while at school. And this is the main inspiration for my robot. It can jump, it's got really smooth movements, and the guy actually shows the parts he used for this robot. So I can basically copy his design. And this guy is called REMRC. Okay, let's talk about why I only got 9 months for this whole robot. At first I wanted something really simple. So I chose cart pole. You just have a cart that moves left and right, and you try to balance an inverted pendulum in the upward position. I shared this exciting idea with my supervisor and he told me, that's boring, you should make a robot. So I'm making a wheeled bipedal robot. This shouldn't be much harder than the cart pole because it's basically the same, you just have the pendulum that has a different height. And also, since I knew I was gonna build a robot dog over the summer, I thought I would just reuse the leg design and wheels and I would have my thesis done. But I was thinking this through and I saw the performance of these motors, like it's fine for fun projects, but I always wanted to try to use actual robotic actuators. So this really complicated the design. And this also means I can't use anything from the robot dog project. Even the microcontroller is gonna have to be different. Now we're getting into the main goals of this project. The robot has to work. This is probably gonna be the hardest thing about this, because if you build something like this, it never works. For example, my hexapod robot, it was nice. I even added some animations. Like I got some cool videos where it looks like it works perfectly, but it never worked. That was like 1% of the time. Now for the actual goals, for the exciting stuff. So I want to use reinforcement learning. I basically want to take this robot, put it in a simulation, teach him to climb stairs, and I'm gonna take the learned policy from the simulation and put it inside the real robot. I actually did a project like this. I don't know if you saw my ostrich robot, that was probably my coolest project ever. But for this, I need the robot to work. I need the hardware to be fine, and since I got so little time, I'm gonna have to choose some creative design practices, which I'm gonna talk about later. You can make the robot balance without using AI. You can just use PID or even LQR. The real advantage of using AI is you can teach the robot anything. I would like the robot to be able to climb stairs. That's the whole reason behind these leg robots, to navigate in tough terrain. and the AI should be able to learn that. I want the robot to be able to jump. And I have to achieve all of this in 9 months. So the final goal is it has to be simple. So I'm gonna buy everything I can and just try to connect the pieces together. If you're interested in robotics or actuators, you're gonna need some PCBs. This is my sponsor PCBWay. They have very good prices for PCBs. You can get 10 2-layer PCBs for only $5, but they do so much more. You could probably build your own actuator just with PCBWay. They do CNC machining like milling and turning, sheet metal fabrication, 3D printing, basically everything. I've used them in all of my projects and they are great. So if you want to check them out, you can click the link in the description and you will get a $5 bonus for your first order. Now we're going to look at the main component of this robot, which are the actuators. I want to take this hobbyist servo motor and explain why I'm not going to use it and why I'm going to use robotic actuators instead. Servo motor, it's basically just 3 things together. It's a DC motor, you apply voltage to the motor and it spins. The higher voltage you apply, the faster it spins. Since it spins so fast, you need a gearbox to reduce the speed, and this also increases the torque so the motor isn't weak. To control the position of the servo arm, you need some type of controller. Usually these servo motors use PID. It's simple, but you only get position control and it's not backdrivable. If you use this for a jumping robot and you smash the robot into the ground, it's gonna break the teeth of the gearbox because the gear reduction is so high. Now let's look at actual robotic actuators. So this is gonna be the specific actuator I'm gonna use. It's a brushless DC motor. It doesn't have brushes, so it lasts longer, it's more efficient, and it offers better control. But just to make this motor spin, you need a controller for that. You can just use DC voltage, it's not gonna work. The gearbox, it's a planetary gearbox, so this transmits a lot of torque, and it's an 8:1 reduction ratio. This is a very low ratio, which is why this actuator is called quasi-direct drive. Because it's almost like you're not using a gearbox at all, it's just 8:1 reduction. With this low reduction, the robot can dampen impact much better, so if the robot just jumps and smashes to the ground, it's gonna dissipate the energy through the motor. And my actuator is gonna have a field-oriented controller, which is gonna offer me to control position, velocity and torque. The main disadvantage of this actuator is that it's more complicated and very expensive. This servo motor costs $10 and this actuator costs $200. So it's 20 times more expensive, and that's why I'm gonna use only 4 of these. Since I want to implement reinforcement learning, I actually need position and velocity control, so I basically need this actuator. So that's why I'm using robotic actuators for this project, and I can't wait to get them. For the wheels, I'm gonna use brushless DC motors, partly because I've never used them and I want to learn something new, and partly because for these actuators I'm gonna control them with CAN bus, which are gonna be just 2 wires running along the leg, and I can just connect another brushless DC motor to it. To send low-level commands to these actuators and motors, I'm gonna use a microcontroller that's capable of CAN bus communication, and I chose teensy 4.1. And to control the robot wirelessly, normally I would build a custom remote controller like this one from my Hexapod, but I have only 9 months to build this, so I'm following a rule that if I can buy it, I'm just gonna buy it. I found Radio Link D8S, I think it's called, and it's just a remote controller you can use for your projects. To balance, the robot is also gonna need some sensors. I think the only thing you need is IMU, and I actually found some IMU which does sensor fusion for you, so that's gonna make my life simpler too. Now, these are the most core components. If I manage to build this robot with these components and it's gonna balance, it's gonna work, and I still have some time left, I want to add the reinforcement learning policy. So with that, I'm gonna have to use Raspberry Pi, because the teensy doesn't have enough power for that. And the Raspberry Pi, it's gonna take in data from the IMU, feedbacks from the actuators. It's gonna calculate with the learned policy how to move these actuators, and it's gonna send position and velocity commands to these two actuators and to the brushless DC motor. I hope I can get to that point, but we'll see. Depending on what actuators I'm gonna choose, I will use either one or two of these 6S LiPo batteries, and I'm gonna either use a 24 volt or 48 volt actuator. So yeah, that's the main design. I'm also gonna show you this in a block diagram form, where it's probably easier to see. If you wanna see the block diagram, how the components communicate with each other, and if you wanna see how I hunted down the exact robotic actuators, which turn out to be pretty difficult, I'm gonna post that on my second channel. These are the actuators I ended up buying. I got Cybergear Micro for $230, and I got Steadywing actuators. This one is for $100 and this one is for about $120. These ones are the same, but they have different drivers. I'm not sure what the difference is, but I wanted to try both of these options because I don't have much time. So yeah, finding these actuators was pretty hard. In the future, I would like to make my own actuator with my own driver. Right now I don't have time for that, so I just buy everything I can. If you look how this robot moves, you can see that there's actually only a single motor here, and he uses this 4-ball linkage to make the foot move in a straight line. I could have actually done this as well, and that way I would have saved a lot of money on the actuators. But since I want the robot to be able to walk upstairs, and I don't want to be limited by the degrees of freedom, I want to be able to climb stairs one leg at a time, I need 2 actuators per leg. So my robot is gonna look more like this. And one thing that's bad about this design is that it's less straightforward to add some springs or something. So if you saw how I made my robot dog's leg, it actually jumps only because it's got springs, otherwise the motors don't have enough power. Yeah, if you look at this robot, he's got springs too. So you can see the springs in the 4-ball linkage, and they probably do the same thing as I do, so they help the robot jump higher. So that's one limitation of this design, but I'm gonna go with it anyway, and if I need more power for jumping, I'm just gonna add the springs somehow. I am very excited for this project. I can't wait to use actual robotic actuators for the first time. You can support me on Patreon if you want to. Hope I won't go bankrupt and I will finish my degree in peace. So thank you guys for watching. This has been part 0. In part 1 we're gonna start playing with the actuators.